Hello everyone, today we're going to go through an exam. I can't remember which one it was, I'll just put exam. I did it before marking it and I got 19 out of 80 and I have nothing to say. However, let's go through the mark scheme together, guys. So, read the question, blah blah blah. Over here we have to find the gradient. This is pretty easy. So basically what I did is that I got this, right? And just counted how much it is until it gets to 40. Oi, chill. And basically over here there's 60 blocks, I guess, and over here there's 70 blocks. And gradients is found by the difference or whatever. Basically this, and this equals 0.86. So the gradient is 0.86. After that, the equation of the straight line, y equals gradient, which is 0.86. I put x and then the y-intercept, and because there's no this, wait, what is the x? Because it's not like this, like the y-intercept, we can't see it. It's going to be 40 because that's where it starts from. So plus 40. That looks so bad, but yeah. And then we have another question. Okay, over here now. So basically over here we have to use factorization. Don't do the mistake that I did. I did two brackets. However, you only need one and the number here to create this formula. So basically it depends when, because basically I think yesterday I posted a video about factorization. Basically it's just maths is confusing, but basically we have to find what creates basically what numbers create 18 and 24. So let's think about the factors of those both and which ones are similar. Over here we can put 6 3, over here 6 4. I just went straight to the point. No, let me do some more examples actually. 2 and 9. 7 and 3. Yeah, just these two examples, 4 basically, I guess. Over here they both have a 6. Over here they have no common factors. So we're gonna choose this one because they both have 6. And what we're gonna do, we're gonna put a 6c, 6c, and then because we need the square one, and then we're gonna put 3 because that's what makes 3. I'll show you. 6 times 3, 18 c squared, because 3c, by the way. No, yes, 3c. After that, 6 times 4, 24c, and then that forms this. So yeah, this would be the answer. After that, calculate, basically read this. So we just, instead of c, we put 24, so in this equation. So, and as you can see, the c is times by the number 1 because they're closed, and over here the c squared. So basically to the point, what we're doing is we're doing 6 times 22. Wait, what I did is that I just did this, basically. 22 squared. 24 times 22. Yeah, I'm pretty sure I did that. Wait, let me check. 18 times 22 squared. Wait, whoa, what did I do on this one? I'm so confused. Yeah. Yeah, plus 24 times 22. Yeah. And I get 924 0. Basically, in the work or the answer booklet, they use a different method. What they did is that basically, this is what they did. 6 times 22 bracket 3 times 22 plus 4. And if, like, I genuinely, I don't know where they got this from. Like, okay, they got the 6 maybe from this 6, but and then they got the 22 because it's over here. But 3 and 4, okay, yes, we used it here, but and what? Oh, I get it now. Basically, do you see the 3 has a C? Basically, yeah, this works too. Use this method because that's one that they use, like in the worksheet. But I guess if you have the answer, then hopefully they won't judge a lot. Okay, and basically just ignore these bits because I did a mistake. Basically question 3. Convert 85 into the radius. Basically, this is given in the worksheet, like basically the equation sheet. It's the 2 pi times the degrees. Degrees is given. And then and then divided by 360. And the answer is 1. Basically, this is the answer, and it will be in rads. After that, calculate the volume of the component. Now here is where we need the equation sheet because I got this one wrong. So there are 3 methods. I don't want to go through all of them. I'm thinking which one's going to be the best, like, for me to remember. I think this one. So the way you work out area is given in the worksheet, and it is the 1/2 and then the degree in radius, by the way. So basically it's 1/2 times 32 squared, the radius is given, literally, times 1483, that equals to 759.96 millimeters squared. After that, the volume, and volume is equal to area times height. We are given the height, so we do this times 50, and the answer is 3964 millimeters cubed. Okay, basically here's the next question, and over here there's 3 methods that they used, but I'll use like the one that I think is going to be the best to remember and like use. Basically, logically, so what I would do, but like, I got this question wrong, by the way, because I did it the wrong way. Basically, just times it by 5 to make this 5x, and then your y is sub, and then so 5y equals 5x, take away 45 times 5, no, 40. So then take away the stuff. So that then leaves us with, what's it called? Oh yeah. So basically this, take away this, take away the y, and then the 2x is left because 5 take away 5x take away 2x. Yeah, that makes more sense. And after what was it? 13 take away 40. However, because the 13 is negative, so like this how it works, it becomes a positive, so it just gets up to 27. We move to 27 here, so x basically equals 9. Then we substitute the y in here, so the x so y equals 9, take away 8, so we move the weight here. No, we move the what do we do? Oh, we answer this 1, so y equals 1. So yeah. Yeah, it's this one. Now this one we use the cosine rule to find a. It's very simple. I talked about it literally in the yesterday's video. One of the two. Oh wait, how much? I can't even remember if I'm honest. Basically, a squared equals b squared. That's what we have in the formula sheet. 2bc cos a. Then we substitute in the values. So 100. It doesn't matter which one you put as b, which one as c. Cos 34, and all this thing equals to 3806.73. Then we square root it because there's a square. So, and we need that a on its own, so we square root it, and a on its own equals 61.69. So yep. After that, we have this. Basically, straight away, just read the question, blah blah blah. The answer is B, free body diagram, because there's nothing else here. It's only the forces and the subject. And then, what is kinetic energy? Joules. Remember, energy is measured in joules. Pardon me. Wait. So over here, the formula is, the mass flow formula is PAV. But like in the actual formula sheet, it was PA1 equals like V1 equals A2, but basically it doesn't matter for this one exactly. So we have the P, we have the A, we have the V, so nothing is stopping us. We just do 120 times 0.02 times 4 equals 81.6 kilogram, because mass is in kilograms. However, because it's in velocity, like we do kilograms a second, Because over here, this is here. So because we use this one, we take the kilogram from this, and over here we don't really take anything from the area, but over here we take the seconds. So yeah, that's kind of it. Basically there was a question 9, but I skipped it because it's a wording question, and I'm not into that type of stuff. Basically over here we have to find what is this equal to, like the UAR, like yeah. So how we find this is the 5 times these two, because that's the whole length. We need the whole length. The whole length is 1.9. 1.9, that equals 9.5 kilonewtons. So it's placed it right in the middle, 0.95, 9.5. So that's the answer. After that, part B, what is the force at RA? So recognize of the moment central, blah, blah. Basically the way we calculate it is that 19 RA is equal to 0.95 times 9.5, because this force, that's what that force is, plus 32 times 0.6, because that's what this force is and where it's located, all that type of stuff. So kind of look, you might think, oh wait, why are we doing 0.6 if we're like it's supposed to be here? Basically the mentality is when you work out RA, you're kind of thinking about RB, because like they're opposite to each other. So like this is equal to this, so you see division. After that, like this is equal to 9.025, and then plus this is equal to 19.2, and then all of this combined, we divide this by 1.9 because we want RA on its own, 0.9, so that equals to 14.86 kilonewtons. Oops, wait, what? Why can't I? Yeah, here we go. No, let me first of all make it smaller. What's the next one? Wait, this one is. So this one was quite hard. So basically over here we're asked to find the velocity of the bicycle. So there are many like formulas that were used here. The conservation of energy, for example. However, I'm just thinking which is going to be the easiest one to remember. Well, for this particular question, probably the Suvat, the Suvat method. So the formula that's given for the Suvat is U, like the initial, plus 2AS, because so basically we have the mass that we can use. We have wait, what? How did it get? They found height by, okay, basically first of all, oh no, wait, I'm confused. Oh yeah, so h is distance, kind of like distance. I would have thought this was distance, but no. Okay, basically how they found height is sine 16, because of the 16 here, equals h. Oh, h divided by 90. So the h is equal to 190 sine 16, which I'm kind of confused about, because why is there a sign? Well, I guess... Oh, it's because it's, what's it called, vertical. Most likely, yes. Yes. Mentality. So the height is equals 54, like 52.4. Doom, 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 doom. Okay, basically after that, the formula, right? So the initial velocity is 0 because it was at rest, plus 2 y2. Why is there 2? Where did they get 2 from? Oh no, that's just, yeah, never mind. 2 is the actual here. Acceleration that... Oh, they didn't use the acceleration, they used the what's it called, the gravity. But I guess it's kind of the same thing because like gravity pulls and acceleration pulls. So, yep. And then all of this equals to 0 and then because it's the v squared, we square root it straight. Oops. 32.1 meters a second because that's velocity. So this was actually a very hard question, and it's not the last one like that. Oof. Dun, dun. After that we have this. Now this is the one that I literally didn't even do because, yeah. Okay, let's think. So calculate the amount of cable extends when the load is Cable extends is this symbol basically, like the difference in whatever. So first of all, it gives us how to calculate the area. So I don't know why we would need it. Okay, let's just, so basically the area is the pi diameter. Diameter is this, and it's squared divided by 4. 0.0004 squared. We could also do pi r squared, however, no need. After that, we have, I think that's sigma, force by area. The force, yeah, is given 0.00045 equals 8 million. After that, we look for the E, which I forgot what is. And it's sigma divided by this 3 thingy. I don't know what it is. It's not a real 3. So then we arrange the formula to find the 3 thingy. So 8. E is this thing, Pascal. I forgot what the name of it, but yeah. And this equals to 1.143. 4. After that, this is equal to this. Basically, you will have to use the formula. Oh my god, this is worth 10 marks. That is actually crazy. Oh no, yeah, basically this is one of the formulas, but we arrange it to have this subject because that's what we're looking for. So this is equal to them squared. That what's this I equal? I'm curious now. Okay, the I equals, oh, it's at L. I guess it's at L. The L equals length 25. 1.143 times 10 to the power of minus 4 times 25 equals 2.86 times 10 to the power of minus 3 meters. Oh my god, that was... Oof. If I have this in my exam, I am like, there's no way I'm alive. But yeah. After that, what do we have? We have this question. So, C, this is our vertical resistor. This is what resistors look like. E, eddy current. Yep. After that, we have this. So, basically, I don't wanna like make it too long. So, how you work this in series? Capacitors are different. The formula is 1CT equals 1C, and there go another. Like for each one of them, it's so this plus 1 over this plus 1 over this. So that's how it is. So all of this is equal to 0.0145. So this is equal to this, but since we want it on its own, we do this, and that gives 68.96, and it's going to be in microfarad. Then it talks about the charge equals CV. We have the voltage, we have the C, like the total. So we times them together, gives us this, and it's going to be in micro coulombs because it's still microohms. So yep. After that we have this. Oh my god, what is this? So an electrician has considered to calculate the inductance. Basically this should be in the formula sheet, and this is basically equal to this, and it's basically these two times each other. These two times each other gives 9060 amps. So yeah, that stands for this. Then calculate the reluctance of the circuit. So like and the S, which I'm not really sure what it is equal to Fm by this. So we're looking for this thing, so we just rearrange it. Oh wait, we'll do no, we don't. We do this divided by this. However, since there's a micro here, it is, and we don't want the micro, we divide it by, so this is equal to 10 to the power minus 3, yeah, and we times this by the previous answer, this. Those two times give us this, and the units, whatever that is, are equal to this. Or it can be h minus 1 minus 1. Oh my god. Oh, now this is the final boss. Basically, we're asked to calculate the current first we're looking for the LXL, which I forgot what it is, and it's equals to this. Wait, can I just, I don't want to explain all of it because, yeah, I don't want to. Okay, basically, XL equals 377 ohms, and this is, this is this, yeah? Yes, this is this. We just calculated this as a resistor, in a way. After we're calculating the total impedance, which equals square root, this is a Z, by the way, Z, 377 squared plus 220 squared, and this equals 436.5 ohms. So now we need to calculate the voltage on its own. So we have, like the V peak equals, no, the voltage equals the peak, V peak, divided by, let me just write it. So, yep. So we do this divided by this, which gives us 222.7. After that, from the formula sheet, we know that I equals V divided by Z, and like the rearrange formula basically. So we divide this by this. So the answer is 0.5 amps. Oof, yep. Thank you very much.